Here, I'm just going to talk about the samples that we have really quickly, and then I'll talk about the tests. So for the samples, we have, I believe, aluminum 6061 is what we're working with. So we're starting off with untreated. Then we have a set of annealed for 1 hour and quenched. So that's our next sample. Then we have the annealed 1 hour quenched and precipitate hardened for 35 minutes. We have same thing but precipitate hardened for 60 minutes. Same thing, precipitate hardened for 2 hours, so 120 minutes. And then our last sample is same thing, but precipitate hardened for 3 hours, so 180 minutes. So we took 3-point bend test data for 5 samples, and then we have Vickers hardness test data for 5 samples as well. You'll see that the untreated we did not take Vickers data for, and the 3 hour precipitate harden we did not 3-point bend test it. So don't stress too much about that. Just know that that's the data that you're actually getting. For the Vickers test, it operates similarly to the indenting and hardness measures done in the Rockwell test, but the outcome measure is a little bit different. I've lost my page. Vickers, that's what we have here. With the Vickers test, we get a indentation, which looks something like this if I take a cross section of my sample. So I get a 3-dimensional indentation in my sample, and I measure force while I'm doing the indentation. So we say that Vickers hardness is the force applied over the surface area of the indentation. And this is measured in units. We say something like VH equals 112, or we say 112 VH, like that. So these are the units we're going to use. We are not using newtons per meter squared, X. We are not using pascals. We are using Vickers hardness. That is what we're using. So please be aware of that. The data that I gave you is unitless in the sheets. So what you're gonna want to do is just make sure you have it labeled on your y-axis. So what I've done is, for each sample, I did 7 indentations. So what we want to look at is Vickers hardness versus aging. So this would be your pH time. So 0 is our first one, 35 is our second one, 60, 120, and 180. Please make your graphs nicer than this. And then at each time, you're going to average the 7 indentations to get a graph that looks something like this. You can join your points if you want to. And this will help you understand a little bit about how the different durations of the precipitate hardening, so how the length of this guy right here impacts the hardness output. This is going to lead you into a concept called overaging, and you guys can read more about that yourselves. For the 3-point bend test data, so there's a video showing you guys how this works. I just want to make a few notes about it. If you recall, when we collected load displacement data in Lab 1, we had a curve that looked something like this for a given like aluminum material. So this was for a tensile test. Let me switch tensile. The 3-point bend test is a compression method on the Instron machine. So the way that your data is going to plot is if you take the data that I've given you, it will plot in the bottom left quadrant instead of the top right quadrant. And this is for a 3-point bend test. And so it's okay. That's completely fine. Let me see if I can, yeah. So I don't need any of this other stuff over here. I'm happy if you just show me your load extension like this. But what I do want is only one figure, please, and please plot your multiple lines however they show up on the figure, and don't use the same color over and over again. Please use different colors, and give me a legend or something so I can understand what I'm looking at, and you'll end up with something like 5 of these sour looking fellows hanging out on your graph. So in this lab, I'm not asking you to do any calculations. I'm asking you for just 2 figures. And this is in order to save you guys work. But you do need to talk about these figures in your discussion. So please cover quantitative information for the Vickers hardness. And for the 3-point bend test, we're not asking you to build stress strain curves. Extension load curves are fine. The samples had identical geometries. So we are able to perform a qualitative analysis in the place of a quantitative analysis. Instead of a quantitative analysis. So if yellow is curve 1, and we have a yield 1, and maybe a UTS 1, and then I'm going to have blue. I'm going to have E2, my yield 2, and then maybe a UTS 2, and so on. Please compare your qualitative yield strengths. Yield 1 is less than yield 2, is less than so on. Is E1 the same as E2? Is it different? And so on. And UTS, same thing. 2, ... And please talk about why they look the way they do, so why you're seeing these patterns. And this is going to go back to the dislocation, enabling versus restricting, and so on. So this page should lay out everything for you. When you're writing your lab for materials, we worked with AL6061, I believe. Since we're doing heat treatments and those are well explained by phase diagrams, you may want to include a phase diagram for 6061. You will want to talk about annealing, quenching, and precipitate hardening of this material. For tests, Vickers and 3-point bend. For expected values, how are you expecting these treatments to impact hardness? Hardness, yield, UTS. So not a hypothesis, but the expected trends from the literature. So you can write one sentence for each of these, however you want to do it. Use a citation. Please cite in text. And explain really quickly expected, instead of values, behavior from the literature. And then equations is not relevant to this one. Methods is same as usual. Results. I've shown you 2 figures. You know what to do there. I've drawn them for you already. Discussion. Summarize, compare, and you've got between materials, between cases, and 2 theoretical expected behaviors. And then please explain why we are seeing what we did. And that's where your critical thinking comes in. Sources of error. We had some variable timings on our heat treatments. So I think at one point I went to get a coffee and I was 5 minutes late to take things out of the oven. Also, the pH 180 cooled in the oven. So that's a much lower cooling rate than we would expect. Beyond that, that's lab 4. In a nutshell, that's some of the theory, what you need to include. I guess this isn't a very good, change that. And if you have any questions, please email me. You do need methods here. You need all your standard components. I'm just highlighting a few that are important. Yeah, and please contact me if you have any questions, and thanks a lot for your time.